I'm having trouble with my thing staying up. There it goes. Okay. All right, so I'm going to go ahead and factor that denominator with you. What do you think we ought to do now? We're solving this equation. What do you think we need to do?
Multiply everything by x plus 1.
Multiply everything by x and x plus 1. And that includes the 0, even though we know it's not going to make any difference over there, right? Because timesing by 0 is just 0. But technically, we are multiplying everything by x and x plus 1. So what happens here? These cancel. Now this right here is going to be a FOIL, isn't it?
Yeah.
X squared plus x minus 3x minus 3. I just went ahead and FOILed it. I know I got like terms. I'll fix that in a minute. Everybody okay with that? Here we're going to cancel and be left with just minus 3x. Here we're going to cancel and be left with plus 3 equal to 0. Very good? All right, let's clean it up.
Wait, I gotta.
Yep.
No. For. Never mind.
So I've got x squared. How many x's do I have?
3.
Well, yeah, there's 3x terms, but what do they all add up to? It looks like minus 5.
5, yeah.
And the 3's cancel. So I'm left with just this?
Yes.
How do I solve that?
Wouldn't the top one be plus x minus 2x? Wouldn't it end up being minus 2x?
Right here?
Yeah.
Yeah, that's minus 2x, but there's another minus 3x from here, so that gives me a total of minus 5. The 3's cancel because one's negative and one's positive. How do I solve that? I can do the quadratic formula, and if I did, A would be 1, B would be negative 5, and C would be 0.
You do negative b over 2a.
Now, negative b over 2a will just give me the vertex of the parabola, so I probably don't want to do that.
Complete the square.
Yeah, Maya says, this guy, just factor it. That's an easy factoring problem. Just pull out an x. Don't forget when we factor, we always look for a GCF, right? Always, and that's that. So x equals what? 0, or x equals 5. And it can't be 0 because that would make that 0. So the only answer to the problem is 5. All right, we have one more of those, and then we're done. With this section. I'm going to go ahead and factor that denominator in number 7, that last denominator. How do you think that factors?
X plus 2x minus 1.
X plus 2x minus 1. I think you're right. So Brooks, what do you want to do here?
You're going to multiply everything by x plus 2x minus 1.
Beautiful. You need to multiply by whatever will get rid of every single denominator. And that will do it. That will take care of all the denominators. So in the first term, when I cancel those out, what will I be left with? On the top here. 3x squared minus
3x.
3x. You're distributing.
Plus 2.
Plus
2x.
2x plus 4, again, you're distributing,
Negative 5
equal to
5.
5.
Subtract the 5.
So 3x squared, let's see, minus x minus 1.
Yeah.
Did I do that right?
Yeah.
Shooty tooty. No factoring here. So what are we gonna do?
Quadratic.
So x equals negative b plus or minus the square root of
B squared.
b squared minus 4 times a times c all over 2a.
Yes.
1 plus or minus the square root of what? Watch all these negatives
13.
in here.
13.
So it'll be 13, which doesn't break down,
Good. So we're done.
so we're done. There they are. There are the answers. Now, I don't want to hear anybody saying, oh, are they extraneous? Kids, the only way they're going to be extraneous is if when you put them in, they make the denominator 0. What's going to make the denominator 0? Either negative 2 or positive 1. That mess is not going to make the denominator 0. All right, next time we have class, we're going to do a practice problem like this, and then you're going to do one on your own. Certainly you have practice in your homework if you want to practice some more between now and then. Everybody good on that? Turn the page, and now we've got something totally different, but something that we looked at back in chapter P. So I think at least part of this is going to be review for you.
This is Florida. So when you said that, I thought we were done with class.
No. You know me better than that, Jayla. We're not going to waste a minute of our precious time. All right, so here we go. This is a totally shifting gears. We just spent some time solving equations that were set up as fractions. This is an inequality. When you see that, you should be thinking number line and shading. We did this earlier in the year. Who remembers what we do with a problem like this?
Oh, you put a 3 and then the 2.
Exactly, Caitlin. We put a dot at negative 2 and a dot at 3. And why are those dots open?
Because it does not greater than
It's
or
not or equal to.
Unless-
Okay? Now, what do I do now?
Shade.
I have to shade. And I have to figure out where I'm going to shade. And Matthew is up here going in the middle.
Between.
Why is it in the middle?
Because it's
He
less than.
is right. Less than is in the middle, exactly. Do you remember that from earlier this year? Unless there is something weird going on, and there is in the very next problem, so beware. Unless there is something weird going on, like squares, if it's just a plain old problem, less than means we shade in between. Greater than means we shade outside. So then we write our answer, and I'm going to write it as an interval because that's the easiest way to write it. So remember how that works? The parentheses mean open dots.
Did you do
So
negative?
this is all the numbers in between negative 2 and 3. Now you could also write it like this. If you like to write it that way, that is perfectly okay also. I really couldn't care less. All right, now, we did a lot of these back earlier in the year. Now we're gonna do some that are a little bit harder, but the ideas are the same. Notice that problem 2 has a squared factor. That changes the game, guys.
Big game changer.
You're gonna start the same way. You're gonna draw the number line, you're gonna put a dot at negative 2 and a dot at 3. That part isn't changing. That part is exactly the same. What's different is that I have no idea where the shading is. So when you put that squared in there, it changes from problem to problem. There is no rule. So here's what I'm gonna do. I'm gonna pick a number over here in this part of the number line. What would be a good number to pick over here? Negative 3. Now I'm gonna put negative 3 into my problem. So if I put negative 3 in here, negative 3, I get negative 1. And if I put negative 3 in here, I get negative 6 squared, which is 36.
Yes.
Now when I multiply, this is a multiply problem, when I multiply those together, I get negative 36. Is that less than 0?
Yes.
Yes, that means I shade that part. When it works, when you stick in a number and you get less than 0 as your answer, then you shade it. All right, now, same thing here. Pick a number. What's a number between negative 2 and 3? Negative 1? I like 0. Can we pick 0? 0 is easier. I'm going to pick 0. So any number will work though. If you want to use negative 1, go ahead. I'm going to use 0. So 0 would give me 2 times negative 3 squared, which is 9. Now that's 18. Is 18 less than 0?
No.
No. So I don't shade that section. All right? Now, pick a number bigger than 3.
4.
4. That gives me 6 times 1 squared
1.
is 6 less than 0?
No.
No. So the only part of the number line that gave me answers that were less than 0 was right here. So my answer is everything less than negative 2. Or, this time interval notation's harder, but if you want to write it that way, you can. I don't care how you write it. Now, why did I have to go through and do all that extra work that I didn't do in the first one? Because of this, right? So we're going to do one more. We're going to do problem 3 because it's got 2 squares in it. All right, dots are at the same place then. That part hasn't changed.
So can we just use the first one and know it's shaded the other way? We just didn't figure that one.
No, because the only way it would be shaded the other way is if it were the same problem and the symbol changed. I have no idea what's going to happen here. Let's put in negative 3. Negative 3 gives me negative 1 squared, which is 1. Negative 3 gives me negative 6 squared, which is 36. Does that work? Does 1 times 36 give me less than 0?
No.
No. All right, let's try our 0 again. 0 plus 2 squared is 4. 0 minus 3 squared is 9.
Yes.
Does that give me a number less than 0?
No.
Okay, let's try 4. 4 plus 2 is 6, squared is 36. 4 minus 3 is 1, squared is 1. Does that give me a number less than 0?
Yeah. No.
So you don't shade.
So what's the answer to this question? There is no answer to that question.
I like those ones.
Nothing got shaded, so there's no answer. Now, if you, Leffel, this is for you, because you have a good, clever mind. Think about this. This, if you were paying attention, you could have told me from the beginning the answer was nothing. Because if you square something, won't this always be positive?
Yeah.
Won't this always be positive?
Yeah.
And if you multiply 2 positives, will it ever come out less than 0? No.
So if it's on a quiz, we don't even gotta do all that work?
Nope, not if it's that problem.
Okay.
I mean, yeah. Okay, so what I wanna do now is hand out your practice tests for this unit.